Okay, sorry I am not there today. I apologize. I think I remember sharing with you guys on Thursday that it's because I got my second vaccine yesterday. So I'm at home today, hopefully not feeling terrible, but just in case I took the day off. You're going to copy these notes and then work on a practice page with the substitute today. So we are moving on to volume, as you guys watched the video on Friday, so this should be vaguely familiar to you. So we're going to start with some formulas. So we're going to start with the formula for volume of a cylinder. Right? So hopefully you guys all know what a cylinder is. I mean, I know my first grader does, so you should know what a cylinder is. But here's our formula. We've got capital V equals capital B times H. And it's really important you have a capital B here because that is actually what stands for area of the base. And that's going to show up in a lot of our formulas. So you need to know that's area of the base. Our base happens to be a circle. And the way you find the area of a circle is pi r squared. So this capital B for this particular shape is going to stand for pi r squared. The H is the height of the cylinder. And V, of course, is volume. So, dot, 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 volume equals capital B times H. In this case, it would be pi r squared, which is our capital B, times the height. Okay, so given whatever shape we have, this capital B is interchangeable. If our base was a triangle, the area of the base would be something different because the area of a triangle is not found by pi r squared. So we're going to jump into a couple of examples here. And I'm going to be showing you how to solve approximate values and exact values. So let's go ahead and actually we're going to skip a line here. Draw ourselves a cylinder. Do the best you can. Right? I usually do just like a skinny little oval and then some sides, and then like this dashed line is to show the dimension, like the depth of it. So our radius is going to be 3 centimeters and our height is going to be 6 centimeters. So for our approximate value, we're going to write our formula, volume equals area of base times height. Then we're going to write what that B stands for, volume equals pi r squared times height. Then we're going to say volume equals 3.14 times, my radius is 3, so times 3 squared times 6, which is my height. So then I'm going to say volume equals 3.14 times 9 times 6. So then I would say, all right, my volume is, and I'd use my calculator, and I would just do 3.14 times 9 times 6, and I'm going to get, hold on a second, 3.14 times 9 times 6 equals, I almost forgot to do this. I'm going to have a squiggly because remember 3.14 is an approximate value for pi. So I'm going to have, volume is about 169.56 centimeters, and then hopefully you remember from the video we label it with a cubed value. So that would be my approximate value for the volume of this cylinder. The exact value is almost the same. We still have volume equals area of base times height. Volume equals pi r squared times the height. This is where, and the reason it's called exact, is we leave pi as a symbol. So now we have pi times 3 squared times 6. Volume equals pi times 9. Here we'll put the pi in the parentheses. Times 6. So because I'm just using this as a pi symbol, I'm not approximating the value. I have volume equals, and this is where we take the 9 times 6 and we put it in front of the pi symbol. And that would be my exact value. This is also called terms of pi. So if someone says, what is the exact value in terms of pi? You can be like, oh, I know that. It's everything, but I just leave the pi symbol. I don't do an approximate 3.14. Okay, so let's try another one. I've got my cylinder here. Right, and don't worry about your cylinder being perfect. Students always stress about what theirs looks like. Just do the best you can. So for this one, I have the diameter of 8 feet. That's the distance across the top. And my height is 12 feet. So I'm going to do the same process. I've got volume equals area of base times height. Volume equals pi r squared times the height. Volume equals 3.14. Here's where it gets a little tricky though. What is my radius? So when I look at this, I gave you the diameter. So what will my radius be? And hopefully in your mind you're thinking 4. Radius is going to be 4, which you're absolutely correct. So 4 squared times 12. So now I have volume equals 3.14 times 16 times 12. Got my squiggles. I'm going to get out my calculator. 3.14 times 16 times 12 is about 602.88 feet cubed this time. Still cubed because remember we're seeing how many cubed feet could fit into that cylinder. So for my exact value, volume equals area of base times height. Volume equals pi r squared times the height. Volume equals pi times 4 squared times 12. Volume equals pi times 16 times 12. Volume is exactly 192 pi feet cubed. Again, we can say exact because we left the pi symbol in there. Okay, so that is volume of cylinders. Let's now take a glance at volume of cones, which you'll find very similar. Just wait for it. Okay, so we have a formula here, just like we did for cylinders. Volume of a cone. So again, we have V equals 1/3 area of base times height. That's it. And maybe you don't know this, but if you divide a cylinder into 3 equal parts, those 3 equal parts would be considered a cone. And it's kind of hard to see visually. I will do my best to explain it to you when I see you in person. But if you think about a cone, here, let me draw it. A cone is kind of like this, right? So if I had another cone here and another cone here, that would basically, obviously this is not a great drawing because it's not all lining up perfect, but think about it being 3 cones make up a cylinder. So that's why it's the same formula, only we're taking 1/3 because a cone is 1/3 of a cylinder. So I've got my volume again. I've got my area of the base. Right? My base still is a circle. So we've got that pi r squared for that capital B, and then h is still height. Okay, so volume equals 1/3 area base times height. Volume equals 1/3 of pi r squared times the height. So how does that work? How do we do 1/3 of something? It's very simple. So let's go ahead. We're going to do the exact same thing we did for our examples of the cylinder. So for example 1, I'm going to draw my cone. Kind of looks like a party hat, right? Got my third dimension there, showing that those little dotted lines there. Now, the tricky part about a cone is that the way to show the height is like this imaginary line coming down the middle, because we're doing the height from the top of the cone down to the base, not the slant height, which I know that sounds strange to you, but slant height is something entirely different. So we are trying to find this, we're going to be given this height and this radius. So our height equals 7 centimeters, and our radius equals 5 centimeters. So we're going to do the exact same thing. We're going to have an approximate value, and we'll also do exact values. So we're going to write the formula. Volume equals 1/3 area of base times height. Volume equals 1/3 pi r squared times height. Volume equals 1/3 times 3.14 times 5 squared times 7. Okay. Now this is where it gets a little tricky, because you're going to want to do something with this 1/3, and that's going to be our very last step. So we're going to go about this as if it's a cylinder, and then the very last thing we're going to do is figure out this whole 1/3 business. So volume equals 1/3 of 3.14 times 25 times 7. Volume equals 1/3 of, and I'm going to do my 3.14 times 25 times 7, and I get 549.5. So here's the last step. How do you take 1/3 of something? Right? Remember, 1/3's weird because you can't just do 0.3. You can't use that. That's not an exact value for third. So the way we take 1/3 of something is in our calculator, we just divide by 3. And that's going to be our answer. So last step, divide by 3. So now I'm going to have volume is about 183.17 centimeters cubed. So the only difference between a cone and a cylinder, finding the volume, is you have this last step where you have to divide by 3 to take 1/3 of that cylinder, which then gives us our cone volume. So for our exact value, remember that's in terms of pi, same thing, volume equals 1/3 area of base times height. Volume equals 1/3 pi r squared times height. Volume equals 1/3 3.14, or no, oops, my bad, this is exact. 1/3 pi times 5 squared times height. So that's going to be 7. Volume equals 1/3 pi times 25 times 7. So volume is going to be 1/3 of pi times 25 times 7, 175, right? So this is where I'm going to do 175 divided by 3. So volume equals 58.3 repeating pi. And then we would say centimeters cubed, right? So because I'm leaving this as pi, then I don't have to change it to 3.14. I can have my equal value. There you go. So that's the difference between exact and approximate, just like we did with cylinders. Okay, so that is how you find for the volume of cylinders and cones. So now you're going to ask the substitute, or maybe the substitute already gave you the practice page for today. All right, I'll see you guys on Wednesday. Thank you.